Hey everyone, welcome back to our third prep video, and in this video we're going to talk about the USACO 2021 February contest in the silver division, problem number 2, Year of the Cow. So in this problem, Bessie is basically given a time portal and she wants to visit n of her famous bovine ancestors who lived long ago, where n is between 1 and 65,536, and using the time portal, she can essentially jump back 12, like in multiples of 12 years. So for example, she can jump back to 12 years, or to 24 years, or to 36 years, but no years in between of those. She can also jump forward. So for example, she can jump from year 36, like year 36 in the past, to year 24 in the past, or year 12 in the past. And however, the time travel makes Bessie a bit queasy, so she would like to prefer at most k jumps through the time. So we're asked to determine the minimum number of years it will take to visit all of our ancestors and then return to the present year, with at most k total jumps along the way. It also mentions that Bessie does not need to use a time portal if she does not want to, and the time portal is connected for the first days of each of the ox year with each other, so essentially she can only jump back in multiples of 12. It was also given that none of Bessie's ancestors live in ox years. So given n and k, and then also the n years in which the ancestors lived, we're asked to find we're asked to find the minimum number of years it would take Bessie to visit all her ancestors and then return to the present year. So let's actually take this input and try figuring it out. So we have five cows over here. So the first thing that we would want to do is obviously sort them, because that would make processing the problem much more easier. So if we sort them, we're given 46, then 85, 95, 100, and then 101. And as you may remember, she can take at most 3 jumps. So essentially, kind of like the best strategy for this would be to start from the back and keep going from the back all the way to the front. And also, she does still need to visit year number 0, because it mentions in the problem that she needs to come back to the original year. So we're going to add 0. We're going to add 0 to the array of years that we have. So it wouldn't really make sense to go to 1 year, then jump back, jump forward, and then jump back again, which is why we're choosing the one strategy of going backwards all the way to the front. So now, how exactly would we do this? Well, we basically want to find the closest neighbor to the last year over here, and see if we can jump back from there. And we want to find the neighbor that's like higher in terms of its number. And the closest multiple of 12 to 101 is 108. So she starts off at 108. So since she can travel from 0 to 108 instantaneously, we don't have to count that jump in terms of the time that we're taking. Then she travels from 108 to 101, which gives us a total of 7 years, from which she travels from 101 to 100, which gives us 1 year. And the closest multiple of 12 that is lower than 100 to 100 is 96, right? So if we go over here, it's 96. So she can either travel to 4, she has to travel to 96 anyways, right? So she travels 4 over here. And now, since she needs to visit 95, she can't exactly jump from 96 to a lower 12, so she has to travel that one distance over here. And the same thing applies when traveling to 85. The closest multiple from 95 to 8 from the closest multiple of 12 that is lower than 95 is 84 over here. And she can't exactly travel to 85. She can't exactly travel to 84 without going through 85, which is her goal anyways. So she has to travel 10 over here, and then she needs to travel from 85 to 84, which gives us her 1. And now, if she wanted to travel from 84 to 46, that would be a long time. And more specifically, the time it would take would be 38 years, and that is a long time, which you could mitigate by simply just jumping. So let's just space this out a bit more. So 0, 46. So the closest multiple to 46 that is higher than 46 is 48. So she could jump from 84 to 48 and not count that as any time because the jumps are instantaneous, and then travel from 48 to 46, which gives us 2. And then from 46, she would want to travel to 0, but in order to do that, that would take 46 years if she just went directly. So in order to mitigate the distance, she would want to jump. So if we look over here, so we see from 46, the closest multiple of 12 that is lower than 46 is 36. So she would travel 10 years to 36, and then she would jump from 36 to 0, saving her a lot of time. So in total, if we sum these all up, in terms of the total amount of time that she traveled, we get 7 plus 1, which is 8, plus 4, which is 12, plus 1, which is 13, plus 23, which is plus 10, which is 23, and then 24, then 26, and then 36 in total. So we get a total number of time as 36. So we see over here that is the correct output. But how exactly can we make a computer do something along these lines? Well, the strategy for that would basically be essentially to take the total amount of distance, so the distance from 0 to the highest, the multiple that is higher than the last number, so 0 to 108, and then subtract the time that is saved by jumping, time saved. So in this case, we can see that how much time we saved. So over here we saved a total of 36 minutes, and over here in this jump we saved a total of 36 minutes. And this gives us a total time saved of 72. So 108 minus 72 is also 36. But now it remains to figure out how we can basically compute the best strategy for jumping and when not to jump. So I'm basically going to create kind of 4 different arrays, or kind of 4 different sets of integers. So for I, which is basically just the index, I'm going to track it as 0, 1, 2, 3, 4, and then 5, right? And the reason why I have 6 numbers is because I added 0 to our list of numbers because we still have to visit 0 at the end. So then for a of I, which is basically just what the values of the array are, I'll be 0, 46, 85, 95, 100, and 101. And now we're going to look at the upper and lower multiples of 12 for each one of these. So I'm just going to start off with the lower. So since 0 itself is a multiple of 12, we can just keep that as 0. And then the lower one for 46 would be 36, the lower one for 85 would be 84, and the same for the next one. And then the lower one for 100 and 101 would be 96. So there we have it. And then for our upper, we see over here, we would have 0, and then for this one would be 48, and this one would be 96, 96, and for these ones it would be 108. So there we have it. So essentially, given this information, how exactly are we supposed to basically figure out the maximum times that are jumped? And the way we're going to do this is by looking at whether or not it is worth it to jump or not. So for example, in this case, let's say we're going from 100, we want to go from 100 to 95. Right? We want to go from 100 to 95. So we see over here that the upper bound of 95 is 96. If we want to kind of visit 95, we have to arrive at 96. But the thing is that the lower bound for 100 is 96. So there's no reason to jump from 96 to 96 because that's not going to save us any time. And the same thing kind of applies for 101 to 100, right? So we see the lower bound from 96, or sorry, the lower bound for 101 is 96. So if we want to jump, we have to go to 96 first. But the upper bound is for 100. The upper bound for 100 is 108. So if we want to visit 100, we have to go to 108 first. Otherwise, we won't be able to visit it. So essentially, what that means is that it's impossible to kind of go to follow our approach of going backwards, so from right to left, given these two lower and upper bounds. So what we can do, however, is look at some of the upper bounds and lower bounds that kind of do end up making sense to jump with. So over here, we see that we definitely want to jump from 46 to 0 through whatever means possible. And in this case, we have to jump from 36, which is the lower bound, after visiting 46. So we go to 46, as we saw over here, we went to 36 and then jump to 0. And the way we can calculate this, the distance of the jump, is simply just the lower bound minus the upper bound, which gives us a total jump distance of 36. And the same thing applies over here. We jumped from 84 to 48 in order to visit 46. And the way we did that was simply just 84 minus 48 gives us 36. So these two, when we get 36. And then we notice that since the lower bounds are either always less than or equal to the upper bounds that happen, we can't exactly jump from those. So at the end, we basically create an array of all the possible jumps. I'm going to call this possible. Right? We create an array of all the possible jumps, and then we sort them, and then we take the k biggest jumps. So in this case, since there's only 2, well, we can take both of them. But in the case that, for example, let's say they were smaller jumps, such as 20 and 5, right? And k is equal to 3, then we would take the k largest jumps that would save us the most amount of time, and then subtract those from our total distance that we had to travel. And now let's actually try wait, before we start programming it, let's look at the algorithm that we can use to basically calculate the lower and the upper bounds of each one of these each number, for example. So if we want to get the lower bound, I'm going to call this, let's just say if we want to get the lower bound, we essentially have to do 12 times x minus 1 divided, and the floor of x minus 1 divided by 12. And the reason why we're doing so is essentially because let's say we have x, and x is equal to let's say x is equal to 5, right? So 5 minus 1 divided by 12 is essentially 0, right? So it gives us the lower bound. So we can and let's say we also have a multiple of 12, even though we probably won't. So let's say we have let's say we have 12, right? If we just said 12 divided by 12, we have 1 times 12, which gives us a lower bound of 12, which is not exactly what we wanted. We would want a lower bound of 0 in that case. But anyways, this algorithm is how we can calculate the lower bound. And for the upper bound, what we can do is essentially 12 times the lower bound of x minus 1 divided by 12, and then plus 12. Right, so basically we're calculating the lower bound and then just adding 12 to it. So that's how we can do it. But there is a special case, so let's say x is equal to 0, then we would end up with 12 as the upper bound, even though we just want 0 as the upper bound. So in just a special case, if x is equal to 0, then we'll just output 0 as our upper bound. So now that we have the process, we can actually try programming this. So over here, the first step I want to do is create the integers n and k. So int and k, and I want to input them. And then what we want to do is create an array, and I'm going to call it, I guess, year of I. So basically the year that the cows lived in. So I'm going to give it a size of n. And I'm also going to set the year of 0 to 0, because we mentioned that we want to insert 0 into every single array that we have. So now that we have that done, what I'm going to do is actually read in the values of year. So for int I is equal to 0, I is equal to 1, I is less than or equal to n, I plus plus, I'm going to input the years of I. And then after I'm done inputting all of them, I'm going to sort them. So I'm going to sort year, and then year plus n plus 1. And the reason why plus 1 is because there's n elements that are filled in here. So that's why I have n plus 1. So now that I have that done, what I'm going to do is I'm going to create I'm going to create a value of like the max distances, or basically the possible values that can be jumped from. So I'm going to call it int max jump, and I'm going to give it a size of n. And then for int I is equal to 0, I is less than n, I plus plus, what I'm going to do is I'm going to say max dist of I is equal to max jump of I is equal to, well, as we saw over here, it's going to be the upper of the current I, sorry, the lower of the next I minus the upper of the current I. But in the case that it's either less than 0 or equal to 0, we're just gonna keep it as 0, because then there's no point of jumping, right? So if that's the case, what I'm gonna do is max 0, and then now I want to actually create the function to get the lower and the upper bounds. So I'm gonna call this int get lower, and I'm gonna give it an int x. And using the formula we derived over here, what I'm basically just gonna do is return 12 times x minus 1 divided by 12, right? And then for the int get upper, we can basically just get the lower and then add 12 to it. But in the case that if x is equal to 0, then we just want to return 0. But otherwise, what we're going to do is just to get lower of x and then add 12 to it. And then we return that. So now what we're going to do is basically get lower of year of I plus 1 minus get upper of year of I. Right? And the reason we did this was basically just to see if a jump is viable or not. And if it is, we're just going to add it to the list of jumps that we have. And then I'm basically just going to sort all the jumps that I have. So I'm going to sort max dist plus n. Sorry, max jump. And then what I can simply just do is take the total distance, and the total distance I'm going to say int dist is equal to basically just the upper bound of the last number, right? Because we're going to do, for example, 108 minus 0, which is just the total distance. So I'm just going to get upper and then of year of n. And once I have that, I just basically have to subtract the maximum jumps. So for int I is equal to n minus 1, I is greater than or equal to n minus k, I minus minus, sorry, not greater than or equal to, it should be greater than n minus k, I minus minus, I'm just going to do dist minus equals max dist of I. Sorry, max jump of I. Okay, so basically the reason why I did so is, first of all, I'm sorting the max jumps, right? So I'm sorting them based on how big the jumps are, right? And then I want to get, in order to get the k highest jumps, I have to go backwards in the array and subtract them. So for example, if I were to sort this array over here, then I would end up with a jump list of 5, 20, 36, and then 36. And then if I wanted to get the k largest jumps, I have to go backwards, subtract this, and then subtract that, giving me my final answer. And then I can just output just the total distance. And that would be my final answer. So let's actually try running this with the sample test case that is provided over here and see what happens. So we do end up with an output of 36, so now let's actually submit this and see what happens. So here I'm about to submit this. So it's grading. So it looks like it's passing the test cases. And yes, it passes all the test cases. So basically to reiterate what we did was essentially input everything, and then we added 0 to our list of years, and then input the year and sorted them in order to make our processing better. And then what we did was we basically took the total distance and subtracted the total amount of jumps that we could do in terms of the distance in order to see how much distance we actually had to travel. And in order to calculate the jumps, what we did was we just took the lower bound of the next year and the upper bound of the current year, and then subtracted them. And if those values were lower than 0, we would just have our max jump to be equal to 0. And then after we were done, we basically just subtracted the k highest maximum jumps that we had, and then output our distance. So I hope you guys understood this, and I'll see you guys in the next video.